So full speed. Your root test is so basic. Here's a root test that isn't basic. This isn't your introductory example. Here we have 1 plus 3 over k to the k squared, not 1k, 2. So we're looking for the root test because we have this exponentiation. When you see the exponentiation, you're looking for the root test. Now here we go. We're looking for the limit as k goes to infinity of the kth root of 1 plus 3 over k to the k squared. Now, I'm over here on the right-hand side so that I can explain what's happening with that exponent. If I had the jth root of x to the j squared, yeah, the j should be on its feet, but now it's in the air. That j squared, that's going to be j times j, but if we take that and we rewrite it as a rational exponent, then we have x to the j times j over j. Then we reduce that j and we just have x to the j, say. That's why over here on the left-hand side, we have the limit as k goes to infinity of 1 plus 3 over k to the k. Now, what is that? That was 1 to the infinity power. So I'm taking it out of what we were looking at so we can just evaluate the limit. Now, we're going to let y be our sequence, y, so that we can take the natural log of each side, y, because we had that k to the in the exponent, and when you have k's in the exponent, after you do the root test, we want to bring it down front. That's what you're seeing here. Boom, I'm using a property of logarithms. And there it is. So now that we have that k out in front, we're going to run the limit as k goes to infinity of the left side. That's equal to k to infinity of the right-hand side. When we look at that, looking like infinity times the natural log of 1, but the natural log of 1 is 0. So we have an indeterminate form, and we need to get it in the form of L'Hopital's. So you've seen this trick before. Everywhere I go, same trick. I'm going to rewrite that numerator and 1 over that other term, because dividing by a fraction is the same as multiplying by the reciprocal, and those are algebraically equivalent. Why did I do that? So that we get a 0 over 0. Now, that is L'Hopital's, so let's go to the Hapio, baby. Now, I'm doing the derivative of the top right there, the derivative of that numerator right there. What is that? That's 1 over the argument, but the argument, if I add fractions, is k plus 3 over k. That's why I have 1 over k plus 3 over k, because it's 1 over the argument times the derivative of the argument. Now, what's the derivative of 3 over k? Yeah, that's minus 3 over k squared. That's derivatives all day, every day. Now we look at the derivative of the denominator. The denominator is 1 over k. So the derivative of 1 over k is minus 1 over k squared. Now, let's simplify that algebraically. What are we talking about? If I take that first piece, that's 1 over k plus 3 over k, dividing by a fraction is the same as multiplying by the reciprocal. That's why we reciprocate, we give back to the problem, and we have k over k plus 3. Now we take a look at what reduces with the remaining factors in that quotient. We see that the k squareds reduce, bam, bam, oh, gone. And what else? Minus and minus make mas, bam, bam, gone. And we're left with just 3. Now we run that limit, and we see your limit is 3. Are we done? No. What is that? Let me take that limit and rewrite it. What we found the limit as k goes to infinity of the natural log of y is 3. We were looking for the limit as k goes to infinity of 1 plus 3 over k to the k. And that's when we let y be that. So we were looking for the limit as k goes to infinity of y. Now, let me rewrite that y as e to the natural log of y. Y. Because they are algebraically equivalent. E to the natural log of y is just y. Now what? The exponential function is continuous, and I can pass the limit up. It's a property of limits and functions, continuous functions. But look at over there on the left-hand side. Whoa, whoa, whoa. We know, no, the limit of the natural log of y is 3. That's why we have e to the 3. Now, what have we done? We've successfully run the root test, and what? Our limit as k goes to infinity of the kth root of 1 plus 3 over k to the k squared turned out to be e to the 3. Is that bigger than or smaller than 1? E to the 3 is bigger than 1. Thus, by the root test, our original series does what? Diverges.